same thing about me, but too bad. Anyway, I'm going to go through this calculating work and mechanical advantage sheet here and see how you did. Don't worry too much if you bombed it, because part of the process is bombing it and understanding what mistakes you made this time and making sure you don't make those same mistakes the next time. Let's look at the first one here. It says Summer uses an inclined plane to lift a refrigerator into the back of her truck. The ramp is 3 meters long and the truck bed is 1 meter off the ground. The fridge weighs 50 kilograms. How much work is done in getting the fridge into the truck? Now, we've got to go back to our conversation and remember that when we talk about these types of questions, whenever it involves an inclined plane, remember the purpose of an inclined plane isn't to reduce the amount of work. The purpose of an inclined plane is to make the work easier. So basically reduce the amount of force that you need. Now there's only one force that we can measure in this question right now. The only force that we can measure is this one right here, and that's basically the force of gravity. So the fridge weighs 50 kilograms, and then we have to figure out, well, if it's 50 kilograms, how many newtons of force is that? Remembering that for every kilogram there is 10 newtons of force. So keep that in mind. This number right here, the 3 meters, not even an important number. Don't need it at all for this particular question here. So let me just change my color to red here so you can see the work as we go, and maybe one day I'll get an iPad and then I can write it, but this works just fine for now. So step one, we got to write our formula. Remember that work is equal to force times distance. So let's substitute now. The force, well, remember the only force that we know is the weight of the fridge in newtons. So we're going to take our 50 times that by 10. That's going to give us 500 newtons of force. Multiply that by the distance. Now the distance is not 3 meters. The distance is getting it in the back of the truck, which is 1 meter off the ground. So if we are trying to lift it 1 meter off the ground and we're applying an upwards force in order to counter the force of gravity, which is pushing down, then we need to make sure that we multiply that by 1. 1 meter is the number we're looking at. So that makes it easy. 500 times 1, don't even need a calculator or anything like that. So it comes out to 500 joules. Then you could write a sentence, Summer does, I'm going to skip the sentences for the other ones, 500 joules of work in moving the fridge into the back of the truck, ... All right, so let's look at number 2 here. These are all real questions. These are all real situations that have happened, by the way. Houston did throw his sister's Barbie doll onto the rooftop. Just kidding. Okay. So Houston has had it with his little sisters, leaving their Barbie dolls all over the floor in his room. He takes their favorite doll and tosses it onto the rooftop. The Barbie weighs 150 grams and has to be thrown 2.5 meters in the air in order to reach the rooftop. What is the minimum amount of work Houston does to retire the Barbie to the gutter? Now, the real trick to this question is this piece right here, 150 grams. 150 grams, remember that when we calculate work, we always need to use force and distance, but distance, and I even said it right here, always entered in meters, force is always entered in newtons. So if we have a situation where, like this one here, the Barbie is not going to weigh kilograms, it's going to weigh grams. What do we need to do? That's right. We need to convert it to kilograms. So first things first, well, how many kilograms is 150 grams? We just have to take, remember there's 1,000 grams in a kilogram. So 150 grams, I'm going to divide that by 1,000, and that is going to give me, it's going to give me 0.15 kilograms. All right? So now that that's out of the way, we can proceed to the rest. Write our formula, work equal to force times distance. Work is equal to, what's the force? Well, in this case here, 1.5 kilograms. We're going to convert that to newtons. Remember, 1 kilogram is equal to 10 newtons, so 0.15 kilograms times that by 10, and that's going to give us 1.5 newtons. So let's put that in our formula, 1.5 newtons times 2.5 meters is how high up in the air it goes vertically. Work is equal to, and I calculate this, 3.75 joules. I'll skip the sentence for now, but there's my work right there. I'm going to highlight all of it, including my conversions, so you can see that nice and easy. All right. There seems to be a lot of people getting upset in these next couple of questions here. So Emily gets so upset at her neighboring classmates, probably Danny, sorry Danny, that she slams her book down on her desk, making a massive ruckus. Her textbook has a mass of 1,500 grams, and she raises it 75 centimeters above the height of her desk prior to ferociously slamming her book down in a fit of rage. How much work did Emily do to raise the book? So read this one carefully and understand that Emily, we were trying to figure out how much force or how much work she does to lift the book up above her head. All right, not the slamming down part, but to lift it up above her head. Now, conversions. We have to do conversions in this one because remember we need to use kilograms. We need kilograms so we can convert that to newtons, and we need meters so that we can use our formula property. So this needs to be converted to meters. Let's do those conversions first of all. So first of all, 1,500 grams, we take the number of grams and we divide it by 1,000. That gives us our number of kilograms, which is going to be equal to 1.5 kilograms. Let's do our next conversion, which is going to be 75 centimeters divided by, there's 100 centimeters in a meter, and that is going to give us 0.75 meters. We are ready to use our formula here. So work is equal to force times distance. Work, substitute now, is equal to, what's our force? So if it's 1.5 kilograms, times that by 10, that's going to give us 15 newtons. Multiply that by the number of meters, 0.75 meters, which is going to work out to, work is equal to 11.25 joules. And of course, we could say Emily does 11.25 joules of work in lifting the book above her head before she slams it down. Now, let me just highlight this in red. I'd be really mad if I do all of this and then I find out afterwards that this isn't recording. So let's hope that doesn't happen. Then I'll be slamming something down in a fit of rage. All right. Part B, doesn't say B, but the second part of question number 3, how much work is done on the desk when the book is smashed down? So smash, the book gets smashed down. Well, in this case here, where is the force being applied? If you said the force is being applied on the desk, you are correct. Okay, so how much does the desk move? If you said that the desk doesn't move, I'm going to assume that you are right because I doubt Emily is going to be strong enough to move the desk, slamming it straight down. The force is going to be driven down into the floor. The floor is not going to move. The desk is not going to move. There's going to be no movement. And what do we know about work? The formula is work is equal to force times distance. If there's a force being applied, but then there is no movement, that's going to be equal to 0. So say that she slams it down with a force of 15 newtons and there's no movement. What's 15 times 0? 0, right? Anything times 0 is 0. So therefore, Emily does no work on the desk because there is no movement. Okay? Makes sense? Oh boy, Bentley, I'm doing a screencast right now, so you might want to stay off.
For what?
For science.
Yes, please.
All right, Colin estimates that he did 500 joules worth of work when he did 2 push-ups. Can you be quiet? Colin's push-ups range of motion from the top of his push-up to the bottom is half a meter or 0.5 meters. Approximately how much is Colin's mass? This one is probably the trickiest question because you have to read it very, very carefully here at the beginning. It says, Colin estimates that he did 500 joules worth of work when he did 2 push-ups. So it wasn't 500 joules worth of work for each push-up. It's for when he did both of those push-ups. All right, so keeping that in mind, let's see how this is going to pan out when I use the formula. Work is equal to force, and there's different ways you could do this. I'm going to show you how I did this. So work is equal to force times distance. In this case here, he's doing a push-up, so he's working against the force of gravity. Say he does 500 joules worth of work. We're going to put it in there as 500 joules. But then I'm going to change the distance that he travels, and I'm going to explain this. So for each push-up, he does 1/2 of a meter lift. Okay, pushes himself up for half a meter. Now, he does 2. So therefore, if we times that by 2, how much is he actually lifting himself up over the course of those 2 push-ups? If you figured out just now that that's 1 meter, you would be correct. Now, having done all this, we're going to be able to figure out exactly how much Colin weighs according to this. So 500 times 1, oops, let's go back here. I need to change the position of something here. We're not finding work here, we're finding force. So I got to go 500 joules is the amount of work, is equal to 500 is the force. Force is what we're looking for, times 1 meter. So when this formula, when you see this situation here, what ends up happening is you're going to have to do a division. So it becomes 500 joules divided by 1 is going to be equal to or 1 meter. Let's just make sure that you're understanding here is equal to our force. So after we do 500 divided by 1, that's going to be equal to 500. So our force is equal to 500. I'm going to just rearrange that. 500 what? Newtons is what it is. But now we can't say that Colin weighs 500 newtons. I guess you could, but it sounds kind of funny. But if we want to convert that to kilograms, we want to divide that by 10, and that's going to be equal to 50 kilograms. And all of a sudden, this question makes a lot of sense. 50 kilograms, that's a pretty average weight for a person your age. 50 kilograms times 2.2 gives you the number of pounds. Now, I don't know if that's actually how much Colin weighs, but it certainly could be. So, of course, I would write a sentence there to finish things off, but hopefully that makes sense to you a little bit. If not, go back and rewatch and forget the little error I made there when I was copying out or doing the substitutions, right? Because here we're finding force, not finding work. All right, it's one of my favorite questions here because it seems the most likely to happen. In a demonstration of his manliness, Brody demonstrates how he can lift the back tires of his quad, or ATV, all the way off the ground. The back end of the quad has a mass of 150 kilograms, and he is able to lift the tires 3 centimeters off the ground. How much work did Brody do during this display of manliness? So this display of manliness is probably going to look something kind of like this here. All right? Brody, not a car, but an ATV. All right, let's go back to this. Carrying on. All right, so display of manliness here. This is our last question on calculating work. So let's go work is equal to force times distance. We don't know how much work he did, but we do know the force, and we do know the distance. So in this case here, we're going to work is equal to, what's the force? Well, it's 150 kilograms. So therefore, times that by 10, that's going to be 1,500 newtons, times the distance. Notice he lifts it 3 centimeters, not 3 meters. That'd be something special, though. 3 centimeters off the ground. So we need to do a conversion here. Let's do our conversion. So 3 centimeters divided by 100 is going to, let's do the little division. A little slash is an easy way to indicate division. Divide by 100 is equal to 0.03 meters. So that's the number that we need to put in there, 0.03. Then we do 1,500 times 0.03. Work is equal to, and that number that I'm looking for there is 45 joules. So to lift that car or ATV 3 centimeters off the ground, that's 45 joules worth of work. So I would come up with a sentence there to finish that off. All right, there's the answer. Now let's go on to mechanical advantage. So Haley is watching Brody in his manly display here, and she decides to show him how to work harder, or to work smarter rather than harder. So she rigs up a class 1 lever and proceeds to lift the back end of the quad 30 centimeters above the ground. So it's going to look something kind of like this. Substitute the car for a ATV. All right. However, the numbers are going to be a little bit different here. So let's go back. So work is equal to force. No, we're not doing that. We're doing mechanical advantage. Mechanical advantage is equal to the load force divided by the effort force. You could also say the load force, you could say, would be the output, and effort force would be the input, because what happens here is with that lever, Haley pushes down with a force of, as you can see, 300 newtons. She pushes down, and on the output side or the load side, it pushes up with a force of 1,500 newtons. So let's continue that formula there. Mechanical advantage is equal to our load force, which is 1,500 newtons. And the effort force with which she pushes down at the other end of the lever is 300. And so our mechanical advantage works out to a ratio of 5. Now there is no unit that follows here. It is simply a number that represents the mechanical advantage. 5 would essentially mean that the input is 5 times creates a 5 times greater force at the opposite end. So 5, anything above 1, and 1 is kind of the magic number, means that you have a mechanical advantage. So this case here, Haley's created a 5 times mechanical advantage. Now let's look at this one here. Reddick likes baseball, and he knows with his new knowledge of third-class levers, he decides to calculate the mechanical advantage when he swings a baseball bat. He figures he applies an input force of approximately 250 newtons to swing the bat. The force the bat exerts on the ball is 50 newtons. Now let's think back a little bit about third-class levers, and we know that third-class levers they're not designed to create a mechanical advantage or a force advantage, but they're rather there to create a speed advantage. So we use the same formula, but we're going to flip-flop some things. Some numbers should get flip-flopped. So load force, I'm just going to go LF just divided by effort force. Now the mechanical advantage in this case here is, well, not mechanical advantage, sorry, the output force or the load force from the swing of his bat is going to be 50 newtons, whereas he is applying a force of 250 newtons to the bat to make it swing. We do the math on that one, and we're going to get a funny number, less than 1, 0.2. And again, no units whatsoever. We're just going to leave it at 0.2. And again, anything under the number 1 would suggest that this is not going to be something that produces a force advantage. But rather, and this is where the second part of this question comes in, what is the mechanical advantage? Well, it's not. What we need to say is this is a speed advantage. And I will highlight that for you. How are we doing so far? Oh yeah, it's not interactive, I forgot. No, I can't. Lily decides, I'm almost done. Lily decides to see what type of mechanical advantage a wheelbarrow might produce. She measures the input force needed to lift the back end off the ground. It's 200 newtons in order to move the load 600 newtons. In order to move a 600 newton load. What is the mechanical advantage? All right, so this is a second class lever. So again, we know that second class levers generally are going to produce a force advantage. We know a wheelbarrow is obviously, in order to carry the heavy loads that you can with a wheelbarrow, you need to be able to produce a mechanical advantage. Sometimes we can just use our logic to kind of figure out where these numbers should be going. And in this case here, logically, a wheelbarrow does produce a force advantage. So our load force is going to be whatever force is inside that wheelbarrow, which is a 600 Newton force, divided by 200 Newtons in order to lift the back end of that wheelbarrow off the ground, which gives us a mechanical advantage of 600 divided by 200, 3. Therefore, we know that we have produced a force advantage. All right, hopefully you guys found this video helpful, and you'll be able to use it moving forward, because you will see these things a little bit here and there. You'll need to know how to calculate one of these for the upcoming quiz. So best of luck.
Okay, you done?
Nope.
Are you still recording?
I am.